The Earth completes a full rotation once per day, and hence the moon passes overhead pretty much once daily. So then why are there 2 high and low tides every day? Simple. The moon's gravitational attraction is stronger the closer you are to it. So the close side of the Earth gets pulled away from the middle, which in turn gets pulled away from the far side. As the Earth rotates, these so-called tidal forces cause water on the surface to slosh around as high tides twice per day, once when the moon is directly over your head, and once when it's directly below your feet. So why is gravity weaker at a greater distance? Well, imagine you're spraying a stream of water at a sheep. If the sheep is more distant, less of the water hits it than when it's close, so there's less force pushing it away. Gravity behaves the same way, except it's attractive. And there are tidal forces from the sun as well. They're weaker than the lunar ones, but when the sun and moon line up, the tides pack an extra punch. It's not just water that sloshes either. Tidal forces cause the Earth's crust to bulge as well. We just don't notice because we get lifted along with it. And tidal forces from the Earth cause the moon to bulge too. All this bulging and sloshing dissipates some of the Earth's rotational energy, causing it to gradually slow down. Eventually, the Earth will spin slowly enough that the same side of the Earth will always face the moon, just as the same side of the moon already always faces the Earth. This means that in the distant future, a day and a lunar month will each have the same length, about 50 of our current days. What's more, if the moon were to get too close to us, tidal forces from the Earth would be stronger than the gravity holding the moon together, so rocks on the moon's surface would literally start flying off into space, and the moon would disintegrate. This would also happen if the Earth were to get too close to the sun, and if you decided to fly into a black hole, it's what would actually do you in. Your spaceship would get ripped apart from tip to tail by tidal forces. Now that's bad tidings.